Okay, we are about to start the meeting. Beforehand, we need 2 volunteers for note takers, 1 volunteer for JavaScript. If you are interested, please let me know. Okay, let's start the meeting. So welcome. This is Mptcp working group meeting. My name is Yoshi. I'm one of the co-chair of this working group. Before we start the meeting, we need 2 volunteers for note taker, 1 volunteer for JavaScript. If you can volunteer, let me know. If anyone for note taking, possible. Anyone can volunteer for note taking? Please raise your hand. Marcel, are you busy? Okay. Anyone? Okay, thank you. And is there anyone who can take care of Java room? You just check Java room, and if there is some people, some comments, go to the mic and then speak on behalf of remote people. Okay, thank you.
That's what I told you.
Yeah. Okay, thank you. Okay. So let's start. Just a reminder. So when you make a comment or questions, please go to mic. And then don't forget, please say your name before you make a comment. And when you submit your draft, please include Mptcp in your draft name so that chairs can keep track the status of the draft. And please don't forget, write down your name on the blue sheet. Okay, this is user note well. So please keep this in your mind. And then this is the current agenda for today's meeting. So we are starting from working group update. And then after that, we talked about the implementation status and the hackathon report. And after this, Alan will talk about 6824-bit update. And after this, we have several presentations for individual draft. First one is efficient design for secure multipath TCP against eavesdropper initial handshake from Dongyeon. And then next one is Mptcp address advertisement load balancing. This is from Fabien. And then last one is proposal for improving Mptcp initialization from Kien. And if we still have a time, we use this time for working group discussion. So currently we're discussing about rechartering. So if we have time, let's discuss about this a little bit. So this is the current agenda plan. If you have any comments, questions, let me know. Okay, so move on. So we have several updates for working group status. Right now, we have 2 working group documents. The first one is Mptcp experience. And fortunately, we mostly done on this draft. So right now, this draft in the RFC editor queue, so almost about to submit, which is good. And another working group item is 6824-bit. We have discussed this draft for a long time, and then new version has been submitted, and Alan will talk about it. So let's discuss about this draft in this session. Any question about the working group items? Okay, move on. So if there is any implementation updates or implementation news, let's share by using this opportunity. If anyone has any news about implementations like Linux, Oracle, any other middle boxes, let me know. Okay. Then yesterday we had a hackathon, and which is related to the Mptcp API, and Benjamin and Fabien organized this hackathon. So I think they have something to update. So let's talk about it. Okay, go ahead.
Hello. So my name is Fabien Duchesne, and I will give you a quick update on what we did during the hackathon. Next slide, please. So for the Mptcp hackathon, we tried something different. So we were 5 or 6 people here in Seoul. But what we did is we advertised the hackathon to our undergrad students. So we explained them, okay, this is what your university is doing, and would you like to get involved? And we were amazed that we get like 25 students that wanted to participate in the hackathon. So we gave them the Mptcp API that has been implemented by Benjamin. And they all had idea and projects. So you can see on the left, they were in Louvain-la-Neuve working. So the thing is, there is a night-hour difference between Louvain-la-Neuve and Seoul. So basically, they were working while we were sleeping, and the opposite. So next slide, please. This is what we worked on. So the first one was a modification of iPerf to support the API. The second one was just allow some programming language to be able to talk to the Mptcp API. So they did that for C#, Python, Java, and Ruby. They also modified some application to directly speak to the API. So they modified OpenSSH, they modified curl, and they modified IETTPD. The IETTPD one was funny because actually they modified it so the server will open a connection or a subflow only after a certain amount of data. This is fine, but it doesn't work because of NATs. But the proof of concept was kind of fun. Like, okay, in HTTP, you can see how big the file is going to be in the header. So they were like, okay, if the file is that big, I will open a subflow. I think if I remember well, it was a few kilobytes. I don't remember exactly what was the setting, but that one was funny. On our end, in the Seoul, we took another approach. We were like, okay, it's not always possible to modify an application. So let's try to do something else. So we made an LD preload library that's you use to call any program. Next slide, please. So what we did was basically this. So you use a LD preload on your program, and then your application do the normal stuff, the connect and things like this. But the library that we added between the API and the application will, if needed, you can. The idea is to put settings like I want to be aggressive and I want to use as much subflow as possible or things like this, and then the library will just do the job and call the API call. So the idea was to make a wrapper to be able to use and modify the application. Not sure if this is optimal, but still it exists. Next slide, please. In the end, the thing is, we won the hackathon. We were surprised, but we did. So probably because of the organization and if so many students participate, but still it was funny. Olivier Bonaventure wrote a long post about it on the blog. So if you want to know more about it, it's on the blog. So you have the description of each project and the result and the slides that the students presented, because at the end of the hackathon in Belgium, each group of students just presented some slides with the results that they achieved and the takeaways they had. So if you want to read more about it, just go to the URL. The slides will be, I guess, on the working group materials. Okay.
Yep.
And this is it. If you have any question. Nope. Thanks.
Yeah, I have one question. So what was the experience? It was more or less quite straightforward while you were running into some issues?
Oh yeah, no, we had a lot of issues. I didn't detail it here because it was just an update of what happens. But yeah, we found some things with the API, like for the moment, we don't have callbacks or any way of knowing if something worked or not. So when you develop the library, yeah, this is an issue. But Benjamin is working on callbacks and he will push them into the API, to the implementation of the API. So yeah, we have some takes away. Like, yeah, definitely, we need feedback. The students had other takes away that are in the slide. Each of them run into some problem. Sometimes it was just implementation specific, and sometimes it was like, yeah, the API, we need callbacks, for instance. So for each project, there are like feedback. You can find that on the slides. I mean, I didn't have time to put everything like.
Library is callback is basically library level one, right? Not the API level one.
No, I mean, when you use the API, you don't have any, for some call, you don't have any information about, like for connect, you don't know if it went wrong or not. So when you want to code a library that will use that, it's complicated sometimes to make some assumption if you don't know if you are connected. So we need some feedback from the API. But definitely Benjamin is working on it, so we'll get it.
So then we will update the API draft as well. Okay. Okay, thanks so much.
Thanks.
Any more comments, questions? Okay, so now next one is 6824-bit Alan.
Okay.
Okay.
Yep.
Go ahead.
Okay. Well, this is a very quick update on what's changed since the last IETF. The main stuff was that Fabien brought forward a number of proposals at the last IETF. Some well received, some we said we take to the list, and so two of these proposals did get. Let's move forward. Two of them did get significant support on the list, so got added, and there's three more that have yet to do so. Fabien, I believe, will present these later. Just as a recap, so this is a assigning of an additional flag in the initial MP capable that says, do not use this address for any return communications. So that this is if you are, if you know you're behind the NAT, or you are a server in a data center and you know you can't accept any incoming connections to the address you're using, you just tell the other end not to even bother. This is just an efficiency improvement. It saves a lot of network resource if you are in one of these situations. Nice and easy. Next. The second one was about adding reliability to AdAdra. We've always been aware this was a problem, but now we're getting into more situations where proxies or load balancers or something might wish to be inserting addresses into the signaling. Then the reliability of this becomes more of a concern. So this is also well received and got added to the draft, and this is about a flag in AdAdra that says, if set, then the other end should echo that option back. So it's kind of compatible with a implementation that doesn't support this, because the only thing that matters when it comes back is that if you've signaled you want it back, it comes back. So you would know it's the one you sent anyway. Simple echoing, simple way of doing reliability for the signal. Next. And then Fabian had more proposals, but I presume there's not any point in me listing these because you're going to do this later. So I'm going to skip this because we're going to discuss these in a second. But just to re-encourage, things only get added to the draft if people talk about supporting them. So please, if you support these things that Fabian's going to propose later, please speak up. That's it. Thanks.
Okay. Any comments? Yeah, actually, I have several comments. Okay, so first one, first C flag stuff. I think this is mostly for load balance, in my understanding.
And devices that are behind NATs, yeah.
And then Christoph also write a draft about the use case for some idea for the load balancing idea.
Yep.
So that we might have two solutions for load balance.
3, there is a draft. Vlad and Fabian have been working on a draft that's summarizing currently 2, and will be all 3 when I actually bother to send some text on potential load balancing solutions. This is not exclusively for load balancers. It's not exclusively for one particular load balancing problem. It's any situation where a device cannot be contacted on that address. I say NATs are a big one there. So let's stop the risk of sending packets back from servers to 192 addresses for no reason.
So basically, it's okay to have multiple load balancer solutions because
even
load balancer, there are several different configurations.
As I say, it's important not to consider this a load balancer solution. It is just it is an optimization that amongst other situations where it would be useful are some load balancer solutions.
Okay. Any comments? Okay, one more question. On the add other. So this is the mandatory or optional?
It's mandatory. You don't have to send it, but you have to be able to echo it back if you receive it.
So all implementation need to implement this feature.
All implementations need to implement the echoing feature. They do not need to implement the sending of it should they not wish to. If they're happy with unreliable address advertisements, that's fine. But if they want reliability, then they need to implement this. That means they've got to cope with exponential backoff and things like that, which adds to complexity. The important thing is the receiver needs to be able to do that echoing, but that's a very simple part of the implementation compared to the sender.
Yeah, it looks simple, but let's say if the other option has been sent with ACK, then echoing should be ACK over ACK.
Yep.
Is it okay? It's a little tricky from my point of view.
That should be fine.
Should be fine. Yeah, I would like to hear the implementation's opinion about this one.
Of course, I think that's delegated to implementations.
Okay. Any more comments? Okay.
Thank you.
Thank you. So next one is, let's see, Donghyun, I think. Which one? This one?
Hi, I'm Dong-Young Kim. I'm master student at Sungkyunkwan University. Please. So I know you're professional about Mptcp, but I explained the introduction. So despite the short history, WordPass TCP prevails drastically. So especially in Korea, communication vendor like SKT, KTLG is advertisement as this technique as GigaLT. So they bound LTA architecture and Giga Wi-Fi network to support 1.17 Giga BPS. So as Mptcp was deployed, security concerns increased. So there have been many attempts at verification to security of Mptcp. So our focus is on initial eavesdropper. So initial eavesdropper in initial handshake breached the primary security goal of Mptcp. So primary security goal is the being no worse than regular TCP security. So we need new solution for these types attacker.
Next slide.
This is basic sequence of Mptcp. So first one is initial connection setup page. So both hosts exchange 16 bits key, and next page adding self-flow setup. So both hosts proceed three-way handshake with MP-join option. So if attackers adding self-flow to original self-flow, it could be problem. So attacker could hijacking the original session. So we need authentication for adding self-flow setup. So authentication is through token and HMAC. So token is just identifier. So token is made by shared key, which is exchanged in initial connection setup. So token is most significant 32 bits of SHA-1 hash output with key B as a message of hash. Next, please. So in Mptcp security, there's basic assumption in Mptcp. So I said the primary goal of Mptcp is being no worse than regular TCP security. So initial connected host should be intended host. So the first connection is compromised. It is not problem for Mptcp. It is problem for TCP because TCP cannot block the initial man-in-the-middle attacker in initial handshake. So if other host, the first connection should be guaranteed. So this assumption is good for using weak authentication. So weak authentication is verified that corresponding host is the one who was in the initial handshake. Weak authentication cannot check the real corresponding host identity, but it ensures the host is the one who was in initial handshake. So yeah, because in TCP nature, there is no pre-shared key, there's no CAs, and there's no trust third party due to the scalability issues. Next, please. So yeah. There are some threat models already defined in RPC, but we only focus on eavesdropper in the initial handshake. So eavesdropper has ability to eavesdropper share key in initial connection setup. So when initial connection setup, both hosts exchange their key, but that procedure is transmitted in plain text. So eavesdropper could see the both key, and eavesdropper make token. So attacker could bypass the authentication. So related solutions are hash chain, MPTLS, and SNDP. So detailed operation is described in the next slide. Next, please. So MPTLS is simply using Mptcp over the TLS. So MPTLS makes the shared key using TLS handshake. So MPTLS needs TLS handshakes. That means Mptcp inherit the overhead of TLS. So TLS share not only public keys, and they share many cipher suits. So TLS handshake's overhead is very big, and not even space overhead. They need more time overhead. So they need additional one-way message delay. So for finishing the TLS handshake, at least 4 one-way delay for TLS, because they need at least 4 additional packets for finishing the TLS handshake. Next, please. This is more efficient version of Mptcp. So it uses TCP crypt. TCP crypt is low overhead asymmetric key exchange protocol using TCP options. TRS shared many things, but TCP crypt focus on only shared asymmetric key and making shared key. So it is more efficient, and TRS is implemented in over the TCP, but it uses TCP options. So it is quite small overhead compared to TRS option. But it still has overheads because SMTCP combined to protocol, Mptcp and TCP crypt. So it has double option header. So one for Mptcp, one for TCP crypt. So this is not necessary thing, I think. So we could remove this overhead, and it need more additional one-way delay. So in SYM packet, we do not include the payload. So they need one additional packet to share the key. So third and fourth packet in initial handshake is for changing public parameters. So they need one additional one-way delay. Okay. No, fine. So the other adding subflow setup page is same. So with shared key, they do same thing in current Mptcp implementation. So okay, next please. Previous two method is based on asymmetric key exchange, and this is other approach. This is different approach. It use hash chain based solution. So it shows make hash chains, so H0 to HN, and it is based on one-way property of a hash. So they exchange H1 in initial handshake, and they reveal in reverse order. So if they want to make subflow, additional subflow, they exchange next hash value. So in second subflow, they exchange H1 value. So due to the irreversible property of a hash, attacker cannot know the H1 even though if attacker knows H1, attacker cannot know If attacker knows H1 hash value, attacker cannot know H1. So the one who knows H1 is the host in initial handshake. So we guarantee the one who knows H1 hash value is the one who in initial handshake. So it is based on weak authentications. But this is great, but it has a row overhead, but it is vulnerable to active attacker in subflow. So basic assumption only guarantee the initial active attacker in initial handshake. So basic assumption don't cover the active attacker in subflow. So it is vulnerable to active attacker in subflow. Next, please. So in summary, in asymmetric manners, they provide security, quite good security, but their overhead is too big. And the other method hash-based solution and current Mptcp security has overhead is nice, but they cannot provide security, not enough. So we need more efficient and more secure protocol. Next slide, please. P4 is the basic assumption only guarantee the integrity of initial handshake. So they do not provide confidentiality. So eavesdropper can get every information to bypass authentications. Eavesdropper can see the both key. So eavesdropper knows the shared keys. So eavesdropper can make hash value and bypass authentication. The solution is asymmetric key exchange, of course, but basic assumption guarantee the corresponding host. The first in initial handshake, the corresponding host is intended host. It guaranteed by basic assumption. So we can use asymmetric key exchange. Without this assumption, asymmetric key exchange is vulnerable to man-in-the-middle attacker, but basic assumption could cover that types of attack. Next slide, please. The other design consideration is space limitations. So Mptcp used TCP option for compatibility to previous system. So without basic header and option headers, we only have 32 bytes for data. So it is quite small for public parameters. So we need to minimizing public parameters to squeeze public parameter into a limited data option header. Next slide, please. So the last design consideration is short connection problem. So in internet nature, there are a lot of short connection. So if short connection occurs, it degrades the total throughput of networks. Mptcp, it is hard to distinguish the lifetime of the session. So Mptcp tried to make adding subflow to every Mptcp session. But if short connection occurs, data are already sent through initial connection. So we don't need to make additional subflow, but it is hard to know. So Mptcp tried to make subflow, and these unnecessary things cause the degradation of total throughput. The solution is already proposed by other researchers. So we use delayed initiation for subflow. So in case of short connection, Mptcp does not make subflow. Okay, next, please. This is our proposed solution. So we use asymmetric key and we minimize public parameter for use elliptic curve, and we minimize overhead for initial handshake. So because since the additional subflow is not mandatory, additional subflow is optional, but the initial handshake is mandatory. So we moved key calculating overhead to adding subflow pace. So if short connection occurs, we don't need to calculate the shared key. And we change some parameter in mpjoin option for security, and details parameter is described in table. Next slide, please. So there is attack, DOS attack on mpjoin. It is in Mptcp, in current Mptcp, valid token in SYN mpjoin makes the host turn into receiving state because the valid token initiate the session, but that token we use in same Mptcp session. So entire lifetime of same Mptcp session. So attack eavesdropper snip that token once, we use until the end of session. So or just guessing, it is only 32-bit entropy. So attacker reuse the valid token. Attacker can get valid token anyway, but they send valid token to victim, tremendously packet to host, but host cannot distinguish. Host think that request is valid because valid token is received. So they open the state. It could be vulnerable to those attack on mpjoins. Of course, limited number of half of state could mitigate this attack, but attacker simply use different 5 tuples to deceive the host. So in our protocol, we change the parameters. So we use token for identifier. So token is just identifier. Token doesn't provide security because token can be reusable. And our security is based on HMAC. So we make another HMAC for token. So HMAC include address ID and token and random nonce bit key. So in our proposed protocol, attackers see the valid token and HMAC and address ID and array, but attacker cannot reuse these things because we include address ID. So if valid user make session to host B with address ID for address A2, attacker cannot reuse it because attacker reuse this value to host B, of course, token B is valid, but address is not valid because address ID for A2 is already used. So HMAC for address ID cannot be reusable. So we could defend those attack on MP-join attack. Okay, next slide, please. There is another attack, address advertisement attack in Mptcp, and this is normal sequence of address advertisement. So host may want to advertise their address when host could not initiate the connection due to the middle boxes. In case of host A only received the connection initiation, host A advertised host A's addresses to host B. So if host B received advertisement packet, he initiate the MP-join connection. Next slide, please. So address advertisement attack is attacker send fake address advertisement packet to victim. So victim does not determine which is the value. So he send token A to attacker. So attacker can get valid token A. So using this token A, attacker could DOS attack on MP-join attack. DOS attack on MP-join. So preventing this, so blocking this, Mptcp version 1 modify this MP-join packet. So MP-join packet include HMAC, but in eBay-stopper model, eBay-stopper knows the key for making HMAC, so it is still vulnerable to eBay-stopper models. Next slide, please.
So point of clarification on that.
Okay.
Is that red arrow meant to come from D1, not A1?
D1?
The fake ad address, is it meant to come from D1 or A1?
D1.
Okay.
But it seems to send from A1. Okay. Next, please. So this is optional advantage. This is additional advantage. So we use asymmetric key exchange. So we can share the key without key exposure. So we're using this shared key for data encryption. So we have two options for use case of this shared key. So we use shared key for only authentication, or we could use this for datagram encryption. Next, please. So this is summary of our proposed protocol. So upper row is our shows our efficiency, and bottom row shows our security. So so our proposed design has low overhead in terms of bytes, because we use elliptic curve. Every other method also using elliptic curve. So Mptcp use elliptic curve, and MPTS also use elliptic curve. So we compare to the overhead in terms of bytes. So our proposed design is less than 150 bytes, and SMTP is over the 200 bytes, and MPTS has TLS handshake overhead, so it is very big overhead. And compared to other method, a symmetric key method has big overhead, but a symmetric method usually support more security than other methods. And we don't need additional one-way message delay time. So SMTP needs one additional packet for exchanging public parameter, and MPTLS needs 4 one-way delays for TLS handshake, but we don't need that. We use 4-way handshake, but second and third packet could send concurrently, so we don't need additional one-way message delay times. And the security part, our proposed design is more secure than others. So in a asymmetric manner, they usually provide more security than others. And the one big advantage of our proposed design is DOS attack on MP join. So we also secure in DOS attack on MP join. So thank you. So our deliverable is 3 design considerations. So FIFO of integrity and space limitation and short connection problem. So based on this security design consideration, we propose secure design for eavesdropper in the initial handshake model. So we have some limitation or discussion points because we only support elliptic curve. It is maybe hard to deployment because we only support elliptic curve algorithm. But we use our plan is use unused flag to reveal our protocol. So if other host, if corresponding host does not support the elliptic curve, we just return to normal Mptcp session because our protocol also provides backward compatibility. And due to the TCP option size, we cannot provide over the RSA 3072 bits security. We cannot provide over than that security. And we don't have real kernel implementation, so we cannot measure computation overhead for our evaluation. So our future work is making real kernel implementation and making evaluation precise. So thank you. This is end of presentation. So
Question?
Alan, can we go back a slide, please?
Where?
Table, the big table.
Okay, this one.
Yeah. Why is MP join insecure in MPTLS?
MP join.
Yeah.
Because that proposed design does not reveal the shared key, but attacker could get valid token. Valid token is reusable, and token initiate the session.
Yeah, but in MPTLS, admittedly the draft is 2 years old, but the general idea was that the keys used to secure stuff was then sent securely. So you couldn't attack on MP join because it would be signed with the keys that you'd exchanged at the TLS level. There are no insecure keys. So how could there be a attack on MP join?
Sorry.
Okay.
Go to this one.
I am his thesis advisor. If I can translate, are you want to comparing MPTLS with the proposed one? So MPTLS.
It says insecure for MP join up there.
Oh, the DOS attack. Yeah, he mentions about only DOS attack, denials of service attack. So his question is why is insecure? Why the MPTLS is insecure in DOS attack? That's his question.
So Mptcp and MPTLS does not reveal the shared key, but valid token could be taken.
Okay.
And valid.
I see what you're getting at now.
Yeah.
Okay.
Thank you.
Any other question? Okay, Doyon, I have naive question. So, okay, this doesn't have to be MPTCP. It could be more like a generic things possible. Why do you do this with MPTCP? Yeah, because no, you can use this framework for TCP Inc. or more generic idea. Why you choose MPTCP? That's my naive question. It's just a curiosity, not a big reason.
I start from MPTCP.
Okay.
Yeah, just.
Okay. And then in order to fit option space, you choose short lengths of the key, right?
Yeah.
Is it secure or how you can evaluate it?
So we can support 256 in elliptic curve.
Mm-hmm.
So it means it provides security RSA in RSAs 3072. It is secure in current
Okay, but current key size is, you can say, secure. Is there any, how can I say, risk to use short key?
So now this is safe.
Mhm.
Maybe 10 years later it is safe, but I don't know for sure. But
Okay.
now it's enough.
Now is, yeah,
Yeah.
that's it. Okay. Thank you.
Thank
Any
you.
other comments? Okay. Thanks so much. Who is next? Next is Fabian. Not this one. This one. Yeah. Okay, hold on.
Okay, so my name is Fabian Duchesne, and this is a follow-up from the last presentation we did at the last year IETF about the address advertisement. Next slide, please. So as Alan said, the two first proposals that we discussed in Berlin and on the list were accepted and put in the RFC, but I will not detail it again. Next slide, please. So the implementation of those two features that have been merged in the draft. The first one is implemented. It's not in the it's not merged in the implementation for now because I need to send the patch to Christophe and then to the review process. But basically, the ad address is now reliable. The only problem is the retransmission is aggressive because for the moment I don't use a timer. I just retransmit it while it hasn't been ACK. So it's a little bit aggressive, but it works for what I wanted to do with it. So I wanted to keep a patch, a very minimal patch. So that's what I have now. When that patch is accepted, I will probably code a timer to retransmit it after only a certain amount of time. But for my measurements, for the moment, it's only retransmitted 1 or 2 times. Even if you retransmit it with every packet once it hasn't been ACK, still it's efficient. For the node joint, it's still under development just because I need to add some states, and yeah, it will be probably done by the next year, IETF. Next slide, please. So for the proposal that haven't been merged in the draft now, this one was to make before after break. Also in Mptcp, we do a lot of make before break. So we establish several subflow like the backup subflow, and we use one when the master subflow has failed. But one of the proposals was to add a backup bit in the ad address, so the server can, another host can advertise an address saying, okay, but this is an address I don't want to use, so only establish a subflow if all the other subflow fails. So it just, instead of establishing the connection and putting it in backup doing nothing, the proposal was just to say, okay, I had this address, don't connect to it. Christophe is supporting it. See, I'm obviously supporting it, but we need more input on that. Do someone have any problem with that? Because, nope. I mean, if we want to get this into the BIS for Prague, we should probably discuss it here on the list, but we need your feedback to merge it, because merging it with only one comment from Christophe saying, I agree with that, yeah, that's fine, but we cannot really do that, right? So we definitely need your feedback. Nobody? Okay.
Any comment? Okay. We can go. We can move on.
Yeah, I will. Nobody commented about it. I mean, Christophe did, but probably because they were lost in the flow of proxy mail. So I will just sum it again. Yeah, proxy. I shouldn't have said that word. So the priority is just allowing an host to advertise to the other hosts. The priority wants to apply to a subflow. So a client could say to a server, please, when you schedule packets for me, use this interface and then this interface. So just put a priority to say, okay, if possible, please send me all the data on this subflow. If that subflow is full, use another one. It's just a way for instance, when you have a smartphone and a server, the server has the server just see two subflow. He has no way of knowing that the smartphone is a Wi-Fi and a 3G. So the idea is to put a priority and just to allow the smartphone to tell the server, please, if you can, just use that interface. Yes, Alan.
Alan Ford, could you not do this at the TCP level by slowing down acts, playing with window sizes, stuff like that?
Yeah, this is not explicit, right? This is hacky. I mean, we really want to put that explicitly. Still, it's a may, right? It's just saying, if you can, please do it. But you probably can tweak it at the TCP level, but it's very accurate, right?
Well, no, you can control the bandwidth pretty effectively. With
Yeah, but how do you allow? Yeah, so you would like the smartphone to slow down at the TCP level. Like, I don't want to use 4G, so you slow down the X on the 4G, expecting that the server will send more packet on the Wi-Fi.
Yeah, why not?
Yeah, because that's pretty hacky. I mean.
It's just a thought. There's just a lot of complexity in Mptcp here, which I'm not sure necessarily belongs in Mptcp.
Yeah, I mean, even if the priority is not rocket science, I mean, it's not very complex. I mean, we came with that idea when we wanted to do a priority scheduler, because this information could be used in the scheduler, and we're like, okay. In the scheduler, it's an easy decision. If you know explicitly what the other ends want, it's easy then to put in the scheduler. But clearly, we can do it at the TCP level. I mean, we can discuss more on this.
Yeah.
I don't know.
I say I'm not opposing. It's just I don't want to see additional complexity, which is unnecessary.
Yeah,
so.
sure.
Do you really need different levels of priorities, or would like one flag be enough saying this one is preferred?
Yeah, for the moment, we have this is almost what we have with the backup and the non-backup, and the problem with the backup is don't use this at all. The idea with different level of priorities was like you could have more than two interfaces. I mean, on server and things like that. Like if you have like one method interface that costs a lot, you put a very low priority. If you have one interface that costs less, you put another priority. It's just more granularity. Do we have a use case for it? Yeah. Probably. In the case of a smartphone, I guess the idea of the, and that's what a question Christoph asked, is it depends of how we define the priority.
So I guess the point is, if you use a link, you use a link. You try to utilize the link. So
Yeah.
it's basically 1-0 decision, right? Either you use it or you don't
Yeah.
use it. So the fact at the end means if you have one flow with a priority bit set, then use this one or one interface. If you don't have any interface with a priority bit set, then use one of the others, I guess.
Yeah, the thing is, and this is why Christoph asked for us to define more precisely the priority, is you could think about like two priorities, 20 and 80. And this would mean you put 80% of the traffic on this one and 20 on the other one. You could just say exactly what part of the traffic you want on each interface. We don't have a definition of the priority now. This is why we need to discuss it.
No, but is it a real use case? So if I have a really expensive link, do I still want to send 20% of my traffic over the really expensive link?
Probably a fraction, but yeah. Yeah, the priority is just to have more than two links. To make the difference between if you have more than two links. Like, I don't want to use it, I want to use it.
Oh, yeah, but that's like 1-0. Use it or not use it. That's one.
Yeah, that's binary when you have two subflow, but do you always want to be binary? Yeah, I don't know. You tell me.
Hi, Brian Dremel. I'm probably going to say about the same thing in
Yeah.
a slightly different way. So when you're doing this balancing across two different links with,
Yeah.
one, you have different costs or other sort of user preferences associated with them. The other thing that you're going to have is different end-to-end delays. Right.
Yeah.
So you actually, if you're in an 80-20 situation and you don't have enough traffic demand to fill up that 80 in the first place, you're going to be balancing stuff off to your LTE thing, and that's going to give you completely different delay, and then you have a bunch of reorder buffering going on the other side.
Yeah, right.
So I think that the way I would phrase it is you make it easy to do the 1-bit thing. And then maybe you have some hacks for people who actually, so I can see what you mean if you have like a constant bitrate stream where there's no sort of like ACK clocking or other sort of congestion that's going to actually throttle that over time.
Yeah.
Then you can say things about 80 and 20. But if you're not using Mptcp for that traffic most of the time.
Yeah, okay. I have no problem with 1 bit priority. I was just explaining why we did it like this, but oh, who is looking at Benjamin? Wasn't you supposed to look at the Java?
Oh, which button?
Christoph?
Hello. With the priorities, one thing I wanted to say is, for example, in the IETF journal that got published now, we describe for Apple how we do the scheduling. We take into account round-trip times. We take into account different metrics, and it's not always a on or off decision. It's sometimes, well, for example, in iOS, we try to avoid cellular, but when the delay on Wi-Fi goes above a certain threshold, we start sending on cellular. And so having a more, and well, the way we deploy this is because we make sure that the server behaves the way we want to behave. Now, if we want to have Mptcp to talk to any server, we would need a way to make sure that the server behaves the way the client wants it to behave. And with today's on or off policies, that's not really possible. So having a more fine-grained control over the scheduler would be good, in my opinion.
So you can have a more fine-grained scheduler even if you have just a 1-bit signal, because you can still decide, yeah, this one is not preferred, but I still send 20% of my traffic over it because that's a local policy. The question is, what do you really need from the client? On what information do you need from the client?
I think from a higher layer, the information that is needed from the client is what kind of traffic is it? Is it traffic that needs super low latency, or is it traffic that needs aggregation? And then based on this, the server can schedule based on that and add some kind of thresholds to it that allow the server to decide, okay, when the delay over Wi-Fi goes, let's say, above 500 milliseconds, then he starts using cellular. At the moment, when a device is connecting to a server, it has no guarantees at all as to the behavior of how the server is going to schedule traffic. And so I think that's kind of a problem for deployment, because on the cellular, you don't want to have lots of traffic on cellular.
But what you just said is a completely different bit of information than just priorities, which, like, for example, having a delay bound or something is something that seems to be more useful to me than just a random priority, basically. And now that I say that, I'm not sure if this is like only Mptcp specific, or if this kind of information could also be used in other TCP scenarios.
Yeah,
it's a kind of QoS.
I agree. There's more needed to it than just priorities.
So that's what we discussed. We were discussing this on the list just earlier. It's how do you classify the priorities? If you want to make a class of traffic, like Christoph suggested, why not? I mean, that's why we need your input on the list to discuss this thing. Because what we wrote in the draft was higher priority, the better. But yeah, we can do something else like the classification of the traffic. I'm not against that. It's just put some bits to inform the other host how you accept him to handle the traffic.
Blaine McDonald, AT&T. I'm thinking about the priority path. I'm probably not going to say much different, but if you have like a path of least resort, or a priority ID of last resort, and I think that'd be suffice without adding an extra attribute to it. Maybe just the other thing I have is that a lot of these presentations are point to point, but really thinking about the usage behaviors on these devices, they're generally point to many points, and really the need for aggregating all that bandwidth into one single point. I don't know if there's much use case and the access space for that. Most of the LTE links or Wi-Fi links can handle 4K bandwidth, and how often are you going to download a huge file? And even BitTorrents allow spreading it across multiple servers. So normal like reverse proxy capabilities or can spread across multiple interfaces, stuff that's been around for 20 years, spread around across multiple interfaces and have more intelligence in that layer. And I think that was when I was reading the Mptcp spec, that was one of the.
Yeah, this is just because TCP is point-to-point, so that's why. This is why. I mean, the transport protocol we are point-to-point. This is why we are focused on this. Even if behind there is something else, even if the server you're connected to aggregates from elsewhere, still you are still talking to one server, and the idea is just to talk to the other host. There is only one other host in Mptcp.
I understand, but I'm a use case from behavioral traffic. That is there really a use case for it in?
Okay.
Sorry.
Hi there. So we're doing something similar to this, but we're actually doing it ourselves on the IP layer. And we found that with priorities, the priorities tend to depend on what service you're delivering to a customer. So in this case, the end user does care about the 4G data because it costs them money, right?
Yeah.
So there's a price associated with that use. So that's very important that you don't spend too much on that, or you allow the customer to at least have some ability to control that.
Yeah.
However, there are also cases where you have purely a server infrastructure where, you might have, I don't know, a bunch of ADSL lines and you want to use all of those, or it could be a bunch of, TCP subflows and you want to use all those, and the cost of the secondary, third, whatever line doesn't actually come into play so much. So priority here actually needs to consider those different use cases. And when the cost of the line doesn't really come in, there are other things as well, like do you want that second line to be an overflow? Or do you just want it to be an extra, something that gives you more bandwidth? Yeah. So there's redundancy use cases as well as overflow use cases. So I think, as some people have said already, that the priority here that we've got so far doesn't look like it will. I mean, it scratches the surface of what people will really want to use this technology for. So, and to answer another one question we had about, do we really need this with 4G, blah, blah, blah. Actually, a lot of people still really have low bandwidth out in the urban areas and non-city areas.
Yeah.
So being able to use your cell connection, if you've got a 2 megabit line or something at home, and you have 3G, 4G can deliver 10 plus megabits, and you can bond the two using this technology, that's actually quite useful. Because it then means people out in the sticks can get things like Netflix at higher quality than, they would have before with just their regular ADSL line, for example.
Okay.
Yes.
I mean, priority is not blocking that, right? You can still aggregate if you put the same priority.
Of course not. But I'm just saying, it's certainly something that's useful, right? Being able to use this 4G line.
Yeah.
Yeah.
Okay. Thanks. The other one was communities. So it was mainly for the dual stack case, where on the same interface you have IPv6 and IPv4. It's not always interesting to establish a subflow to each of these addresses because they are on the same interface. So if you're capped by the interface, it's not interesting. So the idea with that was to allow a host to inform the other host that, oh, this address belongs to the same community. Basically a community, you define that as you wish, but usually it's just, for instance, the same interface. They are on the same interface. So the idea was to be able to know, okay, should I really establish a subflow in V4 and V6 because they are on the same community? So that's the idea, is to give a color to the interface so the other host knows about it. We didn't have any feedback about this. So yeah, Christophe suggested to shrink it to 3 bits, I think, because we proposed 4 bits. I'm not against 3 bits. Again, 8 possibilities is, more than enough. So any comments on this?
How do you know? So how do you know the address is the same, belong to the same interface?
It's user configurable. I mean, that was the idea. You It's an input from the
outside from a Mptcp, from user.
yeah. I mean, for Linux, the idea was to use IP route. So yeah, it's definitely. I mean, probably you can do it automatically. I mean, for the Linux kernel, you can if you say okay, do that on the same interface, you can see which interface you use. So you can probably do it. But I guess the general use case is user configuration. You can change it to say, okay, I want those address because they are using the same peering or something like this to be in the same community. It's not only for one interface. You can just say, okay, those address are bundled because they are using like the same point or the same path. So we can, if it's just for the interface, we can probably do it automatically. But still, I think the user input is important. Like, yeah, if you don't want, if 2 or 3 addresses are using the same peering and the 4th address doesn't, yeah, they will be in different communities. You define, I mean, the user can define communities. That's the idea. Yes, Alan.
Alan Ford. Yeah, I don't think a user really knows this a lot of the time. Yeah, you know they're on the same physical interface, but going to go completely different paths in the network.
Yeah, that's why I say that the user input is important.
Your average user won't know this. Even I don't know what route my V4, my V6 takes. I bet you don't either. I mean, you know, who knows this stuff? It can change.
No, the servers most of the time. It's not really for the clients. It's more for the servers. Because there you have a good idea where your traffic is going. Yeah, I know. Like with my smartphone, I don't know where it's going, but I guessed some big content delivery system, they know where the traffic is going.
Maybe.
And still for the dual stack case, which was the main motivation, it still makes sense, right?
But if they're the server, then they could make an intelligent choice as to which addresses they advertise.
Yeah. What's the problem? I don't get it.
It just seems unnecessary. I'm trying to find the use cases where this would actually be useful.
The stupid use cases, yeah, if I already have something connected to my IPv4, I don't want something to come to my IPv6 because they're using the same path. Yeah, it depends. I mean, on some ISP, you can know it.
As me is saying, you don't necessarily want to announce it. If you don't want something coming to it, then you don't announce it unless you use it.
Yeah, that makes sense. I mean, then you choose not to advertise your IPv6.
Exactly.
Why not?
Or you wait for the client to advertise first to make a decision based on that.
Yeah, makes sense.
Okay. I think the number of use cases where you would have information where this is useful is very limited.
Yeah, I mean, yeah, if we can just scrap it. If it was a bad idea, it's a bad idea. I have no problem with that.
Oh, yeah. It's good to get thinking about it because I read it on the list and don't immediately.
Yeah, that's the thing. But yeah, no. I mean, this is what I wanted. I wanted feedback because if it's a bad idea, let's just scrap it. Yeah.
Okay.
Hi, Jake Holland. The question about how many bits, I just wanted to have a little bit more context. I guess if you're going to scrap it, maybe it's a moot point. But
no, I'm not sure I'm going to scrap it. I'm just saying I'm open to it. I'm not going to defend it until I'm dead, right?
Sure. So I was just, is there, when you talk about automatically selecting addresses, then is this going to, notice and suppress things like if you're running a VM locally and you have like a local LAN that's not going to go anywhere, like would this address be part of the space that would be picked up even though it's useless? If you have a VPN and that's reaching out to the network, and some of these things like add addresses to your machine. So if you're picking them up automatically, then that adds to the count. But if there are several that don't go anywhere, so if the count sort of a fourth bit for me would certainly, if it might include.
Yeah, I didn't. Yeah, you can probably put that on the list because Christoph just said, "Okay, can we spare a bit?" I was like, "Why not?" But yeah, that makes sense. Yeah, we could have a lot of things. Yeah, I think we should definitely put that on the list because it's interesting. Thank you. Okay. Context switching. No, it's. An update on Mptcp load balancing. So we made a draft with Olivier, Vladimir, and Kostin. Next slide, please. So the general idea is a guide to help people to implement or just to choose which load balancing solution they want to use if they want to deploy Mptcp. So what we do in this draft is we describe some of the solution that has been proposed here. Then we compare them. We try to just do a very high-level comparison, like, do you need a public IP address on the server? Do you need to modify the client stack, the load balancer, or the server stack? Next slide, please. So the first solution was the address advertisement that we discussed last thing. It's in the previous drafts. So it's basically you let the flow established on the first flow goes through the load balancer, it's established, then the server will add its public IP address, and then you connect directly to the public IP address. One of the prerequisites was use the IPv6 for that. So yeah, that was the first one that is described in the draft of the address advertisement. Next slide, please. And the second one was something made by Kostin and Vladimir, which aims basically in put the information in the packet. So they modified the load balancer on the server, and basically the load balancer on the server will put information in the packets to allow the load balancing. So one of the proposal is you put the server ID in the secondary subflow is port, and the second one was you just embed the token in the TCP timestamps. So this is another solution that needs a modification of the load balancer and the server stack. So next slide, please. So the idea in general is, like Alan said, now we need to add a third proposal to compare, which is basically the TLS one. We need to write more about the security consideration, because when you say, oh, I'm going to add a public IP address to a server, a lot of people are like, oh, you need to speak about security. So we will definitely do that. And I guess what we need is some input from people working with load balancer, because here we have a lot of assumption about how it works and if it's doable or not. But definitely, if there is someone from Citrix or something like that want to hop on board and give us some feedback on, okay, this solution is realistic, this one isn't. Yeah, we could really use that, because yeah, we're making a lot of assumption, but some feedback from people from the industry would be desirable. And this is it.
Question? Actually, I have one question.
Yeah.
So previously, Christoph proposed some load balancer solution, and the Kostin also proposed some solution. This one is trying to merge everything?
I mean, it's not a proposal to merge everything. It's just like a summary of what we've done on load balancing so far. It's kind of state of the art, trying to just summarize everything we have done or proposed to do, and just compare them.
Okay.
So it's a lot of
just comparing.
Like
okay.
yeah, it's comparing them. We are not reinventing anything.
Okay.
It's in separate draft. This is kind of state of the art, and like to help people that's safe to work with Mptcp load balancing to pick the right solution.
Okay.
Because they are all different. They have pros and cons. So it's just to help people to see more clearly how load balancing and Mptcp interacts.
Okay.
Okay. Thank you.
Thank you. So next is Ken.
Good afternoon, everyone. My name is Kian. Today is my first time in IETF, and I would like to share some research about the multi-party. The title today is a proposal for improving multi-party initialization. Next, please. So basically, I will introduce my idea in 4 parts. First of all, a bit about introduction, and then benefit of the proposal, and how to realize proposal within the domain of multi-party in IETF, and finally its conclusions. Next, please. So our research also similar to others. We focus on wireless mobile networks, which try to use multi-path TCP to aggregate several links. Here's an example with LTE and Wi-Fi. So and we found that the initialization in multi-path TCP, which is the three-way handshake, which is sometimes called degradation of the performance of multi-path TCP. So we propose to duplicate the control packet in the very beginning state and hopefully to make it more reliable and also faster in initialization in multi-path TCP. Next, please. So several researchers also point out in their paper that current implementation or at the moment of the public paper, the implementation of multi-path TCP has a limitation in initialization, which is they don't know how to choose a first path. So because of that, it will degrade the performance in general. So we think that this could be a place we could improve the performance and simply propose a duplication of the control packet. Next, please. So here's two graphs to show a little bit about the potential benefit of our proposal. So in the first one is the default one. So you see the scene capable, scene act, and act, and then scene with the MP-Joy. So this is the default or the current in the current implementation. So we think that why not we send two scenes at the same time. So if the two parts kind of imbalance, so the first returning scene could be choose the I needs part, the first part of for multi-path speed to use. So as you can easily see here, it's definitely shorten the time for multi-path TCP initialization. And in this case, we doesn't consider any loss in the first phase. Next, please. So in some cases, especially in the high wireless speed networks, sometimes the first loss happen in the first phase, and you can see that if if multi-path TCP cannot be initialized, it could be a delay for some value of timeouts. But if using the our proposals, just simply by duplicate the packets, you have a chance to get the successful initialization, and that's for the case of loss. Next, please. So and so far we consider some approach, and we think that only make some modification in sending process in the hosts. It could be enough to realize our proposals, and hopefully we could hear some comment or question from you later. Next, please. So yeah, this is my conclusions. Today I very briefly introduce our idea about some initialization process in multi-path TCP as an introduction for the working group, and we hope that we could have get comment and also update our works in the next meeting. That's it.
Alan Ford, security.
Yes, security also consideration, and we hope that to get the comment from you guys. But in the first step, compared to the current ones, what is I don't see so much different in KF security.
That line, that second line, Yoshi.
This one?
Yep.
This one?
Two SYN packets that share the same destination IP, source port, and destination port belong to the same connection. That's just not going to fly. That, I mean, the risk you have there of session hijacking is vastly increased on what we previously had.
Okay.
Sorry, that's just the immediate thought I have looking at this. It's like, much as I like the idea from like it is almost like a happy eyeballs kind of probing of multiple paths. The big problem is how do you connect the two independent, unidentified sins together? And that's just not enough, unfortunately. Might need to, I mean, it could be possible we could generate some kind of additional signal in the sin, additional keying material that's used once to tie them together or something. But as I say, in its present state, that just doesn't meet any security requirements that I can see.
Okay, thank you very much. Yeah, actually, in current state, we don't consider the security issue yet, but with the comment, it will help us to improve our work.
And I'm actually asking Alan a question, I guess. So if you think about zero round-trip time stuff where you already have security context, and you have a new Mptcp option that would identify those two flows belonging together, do you think there's a solution for it?
Possibly. Okay. It would need analysis.
Thank you.
I have one naive question. Let's say my laptop has Wi-Fi and the Ethernet connection. And then when I want to connect to Google server, but my laptop usually have one single default. And then even if I want to send a packet to Wi-Fi, it goes to wired network. So how you can avoid this kind of situation?
Yeah, so actually for using multi-party CP for the host, actually you need to define the routing table. Okay. And basically that kind of sending scenes out of the computer uses source address, source routing. So you don't need to care about the default gateway.
Okay.
That's the main idea.
I see. Any comments? Okay, thank you so much. Okay. So we still have some meeting time. So maybe by using this time, we can discuss about rechartering a little bit. So these days on the mailing list, we are aggressive talking about some proxy stuff and so on. So first things I would like to discuss is maybe we can add to the charter as a new working group item. And then one possible working item we are thinking is API. So, and then last night, Phil and I have discussed a little bit. And then we are thinking about adding this type of text to the charter so that we can work on API as a new working group item. So basically what this text says, we know we have done RFC 68, 97, and then based on this result, we can extend the API, and then we can work on the new extended API as a new working item. So basic presumption, we don't have to change anything written in RFC 68 and 98, but we can add more enhanced API as a new working group item. That's what we are thinking. And of course, this is just a preliminary idea. So if anybody want to provide a feedback, let us know. Any comments or suggestion? Why? Or if you don't want to add API as a charter, it's also another nice feedback for us so that we can think about. Any comments, questions? It seems many people, I see some support for API as a new working group item. Okay. Okay, let's count the number. Okay. How many people support API as a new working group item? Could you raise your hand? Oh, bunch of hands. Okay. How many people doesn't want to have a API as a working group item? Please raise your hand. Okay. It seems the API seems to have very strong support. Okay, we can work on this one. Thank you. And then next one is proxy. And then this is really tricky one, and so people are aggressively discussing on the mailing list. So, and last night Phil and I discussed and then try to propose some text, but still, we can't. No, we need some time to think about the text. Then beforehand, we would like to clarify several points. And then the first points I would like to check is use case scenario. So there are several discussions about one use case or two use case. And then it seems people want to have both use cases as a working group item. But I just would like to check the feelings of the community. So any comments or opinion about this one? Okay.
I don't really understand this discussion point because it's already in the charter.
Okay.
The working group will explore whether an MPTCP aware middle box would be useful at least one hosting. I'm not going to read the whole bloody thing, it's huge, but it's.
Okay.
I'm not sure what we're trying to talk about adding, given we seem to have most of it in the charter already. Good morning, Phil.
Now, good morning. Does that work?
Yes, works.
So my reading of the charter at the moment is that the one-ended would be in scope, but the two-ended would not be. And I think we should bite the bullet and add the two-ended proxy.
It says where at least one. Sorry, Phil. It says at least one end.
So yeah, exactly. So at the moment it says at least one end. So the one-ended proxy is in scope, but the two-ended proxy is out of scope. So my take, having thought about it a bit, is that if you look at how people are actually using multipath TCP at the moment in a two-ended proxy mode, people clearly want to do it. It has deployment. Let's add it to the charter so that we can do it in a in a IETF context rather than people extending the protocol to do their own solutions. I mean, we should have an IETF solution to the scenario because that's what people are actually doing. And I think we should just bite the bullet and add it myself. That's my personal view. The two-ended proxy, we should explicitly add it to the charter and do the work.
Mia Kuliman speaking as AD. So I agree to you that this is work we want to do in the IETF because people care about. But I didn't hear anything that makes it MPTCP specific. It's work on tunneling, and you happen to use MPTCP for tunneling. And so that's nothing that should be discussed in this working group that actually works on MPTCP as a protocol. If there would be anything that would be needed to be extended in the MPTCP protocol, then this could be in this working group. But actually, as the discussion went on the mailing list, there was a lot of opinions about this is actually something that runs on top of UDP as an application. So it shouldn't be MPTCP specific.
So,
Amelia, can I have one question? So let's say as an operational use case, let's say if we use two proxy in the past, then it doesn't modify anything, let's say. We have some operational experience, and then can this work on it? Or is it out of scope of MPTCP working group?
So you're saying just documenting the
operational, let's say if this is operational experience or guideline, something like that. Is still outside of scope of MPTCP, or can be inside out scope of the MPTCP?
I believe the answer is yes. I'm just trying to think if there's so much difference between documenting operational experience with like one MPTC proxy or two MPTC proxies. I'm not sure if that's a big difference actually here.
Olivier Bonaventure wants to mention that two-ended proxies are not the tunneling solutions.
Yeah, okay. Sorry. Yeah, because we're talking actually about two different things. There are two cases. One is where you have a full proxy, you terminate the TCP connection, and you start a new TCP connection, or in this case, an MPTCP connection. So that's proxies. That's that's in scope, yes. But if you use MPTCP as a tunnel mechanism, that's not in scope.
Okay.
Wim Hendricks, Nokia. Are you particularly referring to the UDP part or the fact that you have a full proxy or a transparent proxy? Because for me, transparent proxy or non-transparent proxy is kind of, okay, we leverage Mptcp, and then we need some extensions in Mptcp, in my view, to actually distinguish end-to-end Mptcp flows versus proxied ones. So we need something in the protocol to actually identify that and identify those flows. And then I think the controversial part is actually the UDP part, but the rest is for me a plain proxy without tunneling.
Hi, Brian Trammell. I'm going to put my banana BOF chair hat on and do a shameless plug at this point. So it seems like there's confusion, but possibly an ability to come to convergence on the non-controversial parts of this. And then there's other applications that you might want to use that might not actually fit an Mptcp. Everybody interested in those sorts of things, come to the banana BOF on Thursday, because it's a non-working group forming BOF, and we're basically going to have a big conversation about how are we, what does this problem space look like? How much of this would go into Mptcp? How much of this, would go over GRE? Let's all get together and try to come up with a game plan. That's the point of that particular BOF. So everyone interested in anything that's not clearly in the Mptcp scope here, please come to Banana.
Okay. What time, by the way?
No idea. Hold on.
Okay.
I'm a bad salesman. It's Thursday, which starts with a T. At 1:30 in Park Ballroom 1. So right over there.
Thank you.
And I'm going to say something slightly surprising in that I think we should just put this in the charter on an analysis framework on the same level that the existing work is chartered for already. I mean, it's valuable to the deployment of Mptcp. It's very close to operational experience, which we've already done documents for or did have in the charter, and so on. It's like, okay, why not write this stuff down? I am very concerned still about any impacts to the protocol from this, but there's no reason we can't go through the process we have anyway for in feeds to the BIS as the basis of this work. So I think I, at this point, agree with Phil. Let's bite the bullet, get moving. Just frankly, remove the words at least one end, and everything else about the charter can more or less stay the same.
Okay, Phil. Phil?
Can you hear me? Oh, right.
Yes.
So also to follow up on that, I think we should. I think it's important for us to understand what impact it has on the BIS protocol. So, that's what we want to understand at the moment, isn't it? Is the BIS at the moment adequate to support the two-ended proxy, or do we need extensions? I know people have proposed solutions which do need extensions, but I'm sure other people have other ideas for how to achieve it. Personally, I would also explicitly exclude the UDP case. So I would say we're supporting TCP, and we're not thinking about supporting non-TCP stuff, because my feeling is that we should leave that sort of thing to Banana. I think in our working group context, it just opens up too much. It's too hard from a IETF process point of view, and it opens up too many technical questions. So I mean, that's my personal view on the UDP question.
Wim Hendricks, Nokia again. I understand that UDP is controversial, but on the other hand, we might complicate things by just removing it. Because right now it's just one option, and it just includes other protocols. Whereas if you exclude it, how would you, we might make a protocol more complex because of IETF, and I think that's not serving the purpose either, right?
I meant to exclude it from us thinking about it.
Okay. But yeah, I agree. Maybe we should first focus on getting a proxy function, single-ended, dual-ended in the charter, flush that out, and then see how we evolve from there, right? I think that might be a good compromise right now.
So Dave Allen Erickson with a question for Phil, which is, if that was excluded from this group thinking about it, but ultimately it resolved itself in requiring an Mptcp extension to do that, and it was considered desirable, what would be the mechanism of taking that forward?
That's one for me. That's too complicated for me to know the answer to that.
Okay.
I mean, it's clearly got to go beyond the working group if that happens.
Right, but just given that there is interest in that, then the question would become is what would be the process in ultimately defining a technical solution for that?
Yeah, Kelvin, the process would be thinking about that when we are at that point.
Okay.
Any more comments?
I'm going to remember that answer, Mia. That's very good. I enjoyed it.
Okay. So, so another discussion point is how much impact we can have on this proxy stuff. It can be, so shall we, think about updating 6824 or 6824 bit draft for this thing, or are we just focusing on how to utilize Mptcp as it is to support proxy? That's probably one of the discussion point. Any comments?
Alan Ford. The charter, I feel, should just cover analysis discussions of the proxy problem. If, as an outcome of any of this, it requires any other protocol changes, it should be fed in the normal way. We probably don't need that to be stated explicitly, is my understanding.
So basically, your suggestion is first we start from analysis, implementation analysis. Okay. Any other comments? Okay, and next discussion point is, there are, this is also very controversial point, but I see sometimes people want to support other protocols, but from the architecture point of view, I'm not very sure if this is right things to do. And also this is Mptcp working group, so I'm not sure if this is, demand to support other protocol. But if you have any comments or suggestions, let me know. Any comments?
Wim Hendricks from Nokia. I think, first of all, I think Banana is not yet formed as a working group or whatsoever. So I think there's a non-working group forming BOF, I think, on Thursday, right? So I think the question is what is in scope and not in scope. I think if the working group would form itself in one way or another, I believe that, and if there is certain attributes with Mptcp could support in terms of Banana scope, we should reference that in the Banana from the Banana working group from the moment it's effective.
Great. So, hi, Brian Trammell, BOF hat chair. So I'm just the BOF chair, so I know nothing. This is really very open-ended. What's going to happen on Thursday? We're going to go through all of the proposals in this space. We're going to see how much interest there is in doing something. We're going to see how much of that work can be done in the existing working groups, if there's a need to do a working group, so on and so forth. The outcome of that will hopefully be a group of people. One of the outcomes could be a group of people who's like, okay, we're going to go and do this work in the working groups that exist. Another outcome would be a group of people gets together and puts together a working group forming BOF proposal for Chicago, right? So, or I mean, if we get to the point where, so looking at it as an outsider who came in to chair the BOF, I think we actually have to have a few more rounds of discussion among that group of people in order to understand what's there and what it looks like. So I don't think that we're going to do one of these things that we have a non-working group forming BOF and then like everything is so perfect at the end of it that we just go ahead and form the working group before the next IETF meeting. But I could be wrong, right? Like I said, I'm just a BOF here. I don't know anything. But yeah, so definitely one of the big things that would come out of that, if that working group gets formed, is making sure that there's not treading on people's feet between Mptcp and Banana, right? Because there's definitely going to be on this proxy thing, if it's in the charter here, and it sounds like it is, there's definitely going to need to be coordination there. Which is going to be like half the people are going to have to go to 2 working groups. So I mean, that happens all the time.
Brian, quick question. So in Banana, do people look for multiple solutions or try to merge single solution?
Yes.
Which yes means single or multiple?
Yes, both.
Which one? Look for single solution or multiple solution?
Oh. Are they looking? Oh, yeah. Then they're looking at multiple solutions.
Okay.
If single solutions exist, then that would be great. But given the diversity of use cases there, I don't see it happening.
Okay.
Yeah. Okay. Yeah. We're having the banana BOF up here, so we're gonna have that on Thursday over there.
No, I don't want to
Okay. Okay. And then last one is, yeah, we already discussed, but we have Banana BOF. So that's if we want to work on proxy, we need to think about how to avoid overlap between the 2 groups so that we don't have to do the same things in the different group. So how to avoid this kind of overlap is kind of question. But we have Banana BOF chair here. So if you have any idea, let me know how to avoid conflict. Okay.
The banana BOF is really because the reason that it's non-working group forming is because we don't know what we do yet. It's an open discussion. As soon as we have a plan what we want to do, that's much easier to answer.
Mm-hmm. I see. Okay. Okay. Okay, thanks for the feedback. So that's based on these feedbacks, I think I feel and I will work on some proposed text about the proxy, how to add proxy as a new charter. But please give us some time. We will think about it. And then next item is we are thinking about if there is any other possible new work items. Yeah, last time there are presentation about using Mptcp for NFS application. And so, and then also from time to time, we see some, congestion control proposal here. So if there is any possibility for adding new item other than API and proxy, please share. If you have any opinion, let me know. Okay. So far, it seems we don't have energy for other topics. So we will think about API and proxy at first. I think that's a consensus of the working group. Okay. Okay, it's a little early, but I think we consumed the whole agenda in this session. Thanks for attending, and thank you so much, and see you in Chicago. Thank you so much.